of cryptography and network security. And once again, good morning to one, good morning to all. If you can hear my voice, then I will be glad. And as I'm waiting to see your responses from the next device, okay? For the next device. So are you able to see the shared screen? Are you able to see the not screen and the board, the whiteboard? Is it clear to you all, the whiteboard? If it is visible, if the board is visible and my voice is audible, you can thumbs up. I can confirm with those who can follow. Are you able to see? Are you able to? Okay, fine. Chandra Sekasi, fine. I hope even you can see me as I thumbs up. All right. So today we are going to have the cryptography and the network security, and we want to look to something called the inverse of modular. We are going to look the inverse of modular. Inverse of modular. Okay. Why this inverse of modular is going to be presented for today's class? Why? Because this inverse of modular, they are mainly, or they are very useful in key creation. When we want to create the keys, when we want to create public keys in cryptography, we use this inverse of modular. The inverse of modular, in other words, it also comes under the so-called the multiplicative inverse. Multiplicative inverse. Okay. In this multiplicative inverse, as we have learned the so-called the modular arithmetic, you remember we have seen the modular arithmetics. In the modular arithmetics, remember in arithmetics we have different operations such as addition, subtraction, okay, multiplication, even divisibility. But we don't deal with this visibility, rather we deal with the multiplicative inverse. So if we want to know the inverse of a given number, let's take an example. We have the set of, we have the set of 10 integers. Okay, if we want to find the inverse, okay, of all, let me say all element, okay, all elements of set Z10, okay, the inverse of all elements of set Z10 in, okay, additional arithmetic, we say in additional arithmetic, in additional arithmetic, what do we do? Arithmetic, what do? We want to know all the numbers, all the integers, which can give the residue which is equal to 0. I repeat again, in additional arithmetic inverse, for additional arithmetic inverse, I write here, for additional, for what? For additional arithmetic inverse, you can, like a vendor, you can mute yourself. Very good, Kevin. Yeah, you can the additional arithmetic inverse, the residue is equal to 0. Okay, to 0 for addition. Okay, keep in mind we are looking at the addition and multiplicative inverse. In the set of Z, I come back to this set of Z, means set element, means from 0 to 9. In addition inverse, we want to have the residue. Remember, residue in so-called extended Euclidean we have seen as a remainder, but in modular we call as a residue. Residue should be equal to 0. Whereas in multiplicative inverse, where in multiplicative inverse, the residue should always be 1. Should always be, let me write in letters, 1. 1 means we have to have only 1 as a residue. Is it clear? We have two things, as you see. We have two things. We have a multiplicative inverse and so-called additive inverse. Additive inverse, very important topics to understand, and you have to be very wakeful and thoughtful. We took an example. This z, it can be even set of integers n. It can be any given number. Yeah? First, I want you to understand this. If you want to know that a given number, a given integer has an inverse in a set of integers, if it is additive inverse, the residue should be equal to 0. In a multiplicative inverse of modular, the residue should be equal to 1. I hope this is very clear. All right? So now let's see how these things works. We are going to see how all these things works. Okay? For addition is very simple, but for multiplicative inverse is quite technical. That's why you have to follow and do as I do. All right? We took an example of set Z element 10. Addition to this, because before I go further, addition to this, for the set of integers, since the inverse of additive number is 0, then the elements which can give the number, the integers, which can give the residue of z below 10, for example, if you take 1 plus, we say 1 plus 9 mod of, let me erase this one. I hope you have written this one. Let me take for this additive in inverse. For this is for z in additive. Okay. Let me erase here. Let me erase here, and I come here. Okay. If I say the additive inverse. This is additive inverse of set of integers. Okay, set of integers z10. Okay, when we want to find this additive inverse of set of integers 10, what do we mean? This means, okay, all elements, okay, which are below 10, below 10, okay, when below 10, when are summed up, when you sum them, the residue gives what? 0. When you sum them, let's take an example. Here we have the elements or the integers. The set of z means all the integers, the element of set of z, we mean from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Why? Because the set of z, we say z set of integers n is equal to 0 till where? Comma 1, comma 2, till n minus 1, n minus 1. So now, as you can see, I want you to be wakeful and to unmute yourself and tell me, what are the numbers which we take, let's say, mod of 10, okay? What are the numbers we can add and they give the residue is equal to 0? What are those numbers? What are those numbers? What are those numbers? When we add, as you can see the set of integers, look here. What do we have here? Here we have the set of integers, 10. And we want to find in these elements, you see, element 0, element 1, element 2, element 3, element 4, element 5, 6, 7, 9. We want to know which number can we add and they give the remainder which is equal to 0 in this one. Is it possible? I want you to unmute yourself. If you take 0 plus 1, what is the remainder? 0 plus 1. What is the remainder for this one? 0 plus 1. What is the remainder? Unmute yourself and tell. You can unmute and tell. 0 plus 1. What is the remainder? Unmute yourself. If you don't, I will call you by names, or I will tell all of you to come on video. For those who can hear my voice, please come on video mode. For those who can hear voice, please come on video mode so that I can confirm how many are there. Okay. For those who can hear my voice, for those who, yes, Jivan, he can hear. Yes, Vinita can hear. Yes, Biswajit can hear. Next, Prince can hear. I want all of you, for those who can hear my voice, excellent, good, well, good, well, good. Okay, there we go. Now, the remainder, yes, all of you can come, yes, the remainder of 0 plus 1 mod of 10. What is going to be the answer for this? Yes, what's the answer? When you take 0 plus 10 mod of 10, we have seen from the previous class. I just want to go one by one, okay, so that you can understand this multiplicative inverse and additive inverse, okay? What is the answer for this? What is the remainder? Jivan, let me call by name. Yes, Jivan. What is the remainder or residue or the answer for this?
Sir, there is background noise much suffer.
Well, your background is noise. Okay.
Yes.
Okay, but I can hear. No problem. I can tolerate. What is the answer? I just want to. Yes.
0, sir.
How come? Wrong. Very wrong. Even if you don't understand this, I think you were absent when we started this modular arithmetic. Is equal to 1. Yes, is equal to 1. You were absent. This one is equal to 1. And keep in mind, when we want to find the additive inverse, the addition of the two integers or multiple integers should give 0. So which means 0 and 1, they cannot make the additive, they cannot find any additive inverse. Clear? Now, let's go on. If I take the pair of 0, 0, 0, 0, what is the remainder for this? 0, 0. What is the remainder for this? 0, 0. 0 mod of 10. 0 mod of 10. The remainder is 0. Okay? Which means the pair of 0, 0, they can give us additive inverse. Now, if we take 2 plus 8 mod of 10. Okay? What is the remainder for this one? 2 plus 8 mod of 10. What is the remainder for this? Remainder? What is the result? Or what is the residue? We call them residue or remainder. Yes?
0.
What is the answer? 0. Excellent. So the pair 0, 0 give inverse, additive inverse. 2, 8 give inverse. Keeping in mind why? Because the remainder or the result is 0. Correct? Now, let me take one more element. If we take 5, 5, if we take 5 plus 5, okay, mod of 10, they give 0. If you take 3 plus 7, mod of 10, they give 0. And if you take 4, if you take again here, 4 plus 6, okay, mod of 10, mod of 10, they give what? 0. So and so on. As you can see, we may have like a 5, 5, 3, 7, 6, 4. What else? Do you have another one? We have only 4. 1, 2, 3, 4, 5. So we have 5 pair elements of Z10, which can give us additive inverse. For addition is quite simple. You just only need to know what is going to be the remainder of these additions. Okay, simple. Now, come to the important one. I repeat once again, this multiplicative inverse is very, very important. Okay, that's why I want you to be wakeful, thoughtful, and you have to have a doubt and a question in this multiplicative inverse. Remember, in multiplicative inverse, in this multiplicative inverse, we want to have a mod of, let's say, 11, okay, set of integers 11, where the residue or answer should be 1. What does it mean? Here we mean a into any given number. Let's say a into m. M can be a given number, mod of 11, okay? This has to give us 1. Now, in a set of 11, okay, set of 11, what number can we multiply and then they can give the residues equal to 1? Okay, so in this multiplicative inverse, the set of integers start from 1, 2, let's say 1, 2, 3, and it goes on to say till 10. Okay, till 10. So here we start from 1 because the residue is equal to 1. In the additive, if you remember the additive of number, we start from 0 till n minus 1. But here we start from 1 till n minus 1. Why? Because we want to have the remainder, which is the least number is 1. The least is 1. Okay, keep in mind. And this is symbolized by star. We shall see. Okay, we shall see. All right. So when we want to find this, we want to find this number. Which number? Keep in mind, this number will be as a secret key. Okay, that's the purpose. That's the aim of this arithmetic. Okay, this inverse. This number will be taken as a secret key. It's used to calculate the secret key. So now, let's take an example in mod of 11. Let's take example 5 mod of 11. Okay, 5 mod of 11. Find, you can say, find the multiplicative inverse. Multiplicative inverse. Okay, multiplicative what? Inverse. We want to find the multiplicative inverse. Okay, which number can we multiply by 5? Okay, mod of 11, and we can give the residue which is equal to 1. That's the third. Okay, this is the third. Which number we want to multiply by 5, and we give the module, or we give the remainder which is equal to 1. That's what you want to calculate. All right. So watch here and calculate. Take a paper and a pen. Go along with me. All right. All right. So you can go along with what? Along with me as I do. 5, we want to find 5 mod of 11. How to calculate? To calculate this one, okay, to calculate multiplicative inverse, to calculate multiplicative, okay, multiplicative inverse, what do? We, okay, use extended Euclidean algorithm. Euclidean what? Euclidean algorithm. Okay, that's what you're going to use to calculate or to find the inverse of this number. This is so to say, you want to take 5 into x. X can be any number, mod of 11, and we have 1. Okay, we have 1. Please follow if you have a question. Don't end the session, don't go out of session without asking, because it's a matter of understanding how it works so you can go along with. Now, we are going to calculate the extended equilibrium of 5 and 11. How do we do? Let's take this example. And the rule says, without forgetting, the rule says the GCD of A comma N should be equal to 1. If the GCD of 5 and 11 is equal to 2, then you know that those numbers, those integers, they don't have multiplicative inverse, period. Over. If the GCD is something else like a 2 or 3, you know there is no inverse you cannot calculate. Clear? Now, the GCD of 5 and 11 obviously is 1. Okay, is 1. Why? Because there is no common number which can divide 5 and which can divide also 11. That's why we have to satisfy this one. So let's do this in extended equilibrium. 11, let's say 11 is equal to 2 multiply 5 plus what? 1. So to say, for those who are weak, for those who were not there when we calculate this one, we mean that is a 5 divide 11. I put 2 is going to be 10 and the remainder is 1. Okay, the remainder is 1. So next, here we have a remainder. This is a dividend. This is what? This is the divisor. This is a dividend. This is a quotient. Okay, this is a Q for extended equilibrium. This is a Q. This is we take as R2. This we take as R1. This is take as R. Clear? What is next? Next, R2 is going to be what? R1 means you're going to be 5. Okay, 5 is equal to what? 5 is equal to 5. Okay, into 1. R is going to be R2, and the remainder is a 0. You get what I'm saying? You get what I'm doing here? Don't get lost here. In extended equilibrium, keep in mind, remember, in extended equilibrium, let me shape it here. Let me shape it here so you can understand it, okay? And we go parallel. That's why I said you have to be thoroughly understand this, okay? You have to thoroughly understand this method, okay? Let's come here. Here we have Q, extended equilibrium. We have R1, we have R2, we have R, okay? And here, our problem or our given integers, we have R1, which is equal to 11, R2, which is equal to 5. We substitute them here, 11 and 5. And when we divide, we put here, this is a quotient, 2, this is 1. This is going to take a place, 5 and 1. We put what? We put 5 quotient and the remainder is 0. This is comes here, okay? R1 becomes this one, which, what does it mean? We mean and 0. We mean the GCD of these two numbers, the GCD of what? Of 5, 11 is equal to what? Is equal to 1. Because the GCD is equal to R1. Okay? R1. I hope this is clear for you all. Now, the next method, which is going to help us to find the multiplicative inverse. What is that? The next method to find this one. This is so to say that 11 is equal to 2 multiply 5 plus 1. See here, 11 is equal to 2 multiply 5 into 5 plus 1. Now 5, what is the value of 5? Now we come here to this 5. 5 is equal to what? 5 is equal to 5 multiply 1 plus 0. Okay? 5 multiply 1 plus what? Plus 0. When you reach to 1, yes, please. Yes, anybody called me? Someone called my name. Okay. Okay. Okay, fine. So As you can see, when we reach to 1, no need to proceed to calculate this one. This is not needed, okay? This is not what? Needed. Now, what is the value of 1? 1 is equal to 11 minus 2, okay, into 5, okay? Minus 2 into 5. Remember, we want to find a number which we can multiply by 5 and mod of 11 and the residue is equal to 1. Now, if you take minus 2 mod of 5, okay, minus 2 into 5 mod of 11 is going to give us 1, correct? Are you getting what I'm saying? If you take minus 2 mod of what? Mod of 11 minus 2 into 5 mod of 11, the residue is going to go to 1. Let me write here. If you don't take a note, please you will get a lost. And when you get a lost, then you won't understand. And if you don't understand, then you won't be able to cope up with the next topic. Okay, that's the deal. Okay, so now, what do we say? We find the number because this is a minus 2 into 5 should be equal to 1. Okay, now we come here, minus 2, okay, into 5 mod of 11. Let me multiply, let me use multiplication sign here, into 5 mod of 11, they give us 1. Remember the third rule. When you have multiplicative, what do we do? This is equals to say minus 2 mod of 11 into 5 mod of 11, okay, and then finally we come to get what is the answer. Okay, now minus 2 mod of 11. Let's first calculate this one. Minus 2 mod of 11. What is the answer for this? Minus 2 mod of 11. What is the answer? I want you to calculate this one. Minus 2 mod of 11. What is the answer for this first? Give me the answer. If you find the answer, then all is done. Okay. Minus 2 mod of 11. What is the answer for
9,
this?
sir, 9.
9. Excellent. 9. 9. Excellent. 9. How 9? Because we cannot divide. This should be a positive number, and also the remainder should be a non-negative number. Keep in mind, the residue should be greater or equal to 0. Why 0? Because additive inverse can give 0, right? The residue can be equal to 0. Now is equal to 9. We take the module minus what? That integers which you have on this side. Okay? Now is equal to 9. As you can see, when you take 9 into 5 mod of 11, what is the residue for this? What is the residue for this one? What is the residue? What is the residue for this one? What is the residue for this one? 9 into 45 mod of 11. What is the residue? First, very simple. Tell me, 9 into 5 is equal to what, Sharwin Lakla? Sharwin, 9 multiplied 5. What is the value for this? Sharwin. Sharwin is there? Sharwin Lakla, where is Sharwin? Yeah, I think she's there. Yeah. Yes. 9 into 5, what is the value? Is equal to 45, right? 45 mod of 11. Now, 45 mod of 11 divide 11. We put what? 4 is going to be 44. The residue is 1. Correct. Now, the multiplicative inverse of 5, now we say insert Z11. Okay, the multiplicative inverse from 1, okay, to 10. The only number, or the only integer which can be the inverse of 5 in the mod of 11 is only 9. Okay, 9. So we say 9 is the inverse. 9 is the inverse of what? 5 mod of 11. Period. Done. Okay, done. This is how we calculate the multiplicative inverse. Okay, this is the way we have to calculate multiplicative inverse. Since you have a time, I'm going to give you the second example. The second example. So the third example will be done by you, all right? Will be done by you, okay? So I told you, if you don't write down, you won't understand, my dear, okay? Let me take one more number. Let me take 45, okay, and 4. Okay, 45 and 4. Okay, 45 and 4. Let me write this as like this one. Okay, 45 and 4. Please, for this, those keep in mind this one. Find, okay? Find what? Find multiplicative inverse, multiplicative. Okay, inverse of what? Of uh, uh, 5. No. I said what? 4. No. Yeah, 4 mod of 45. Okay, mod of 45. All right. What do we do here? What do we do? We are going to use the extended Euclidean. If the GCD is equal to 1, then we proceed, we find the multiplicative inverse. I use both the ways. I will use both the ways. As I do as well. Okay, do as well. I have to find Q. Very simple. I have to write this as a Q. Okay. I have to write this one as what? I have to write this one as a Q. I have to write this one as R1. I have to write this one as R2. I have to write this one as R. Correct? All right. So 45 is equal to what? 45 is R1. Okay. 4 is R2. Now we divide. We take 45. We take 45 divided by 4. Correct? I put what? If I put 1, it's going to be 4. It's going to be 0, 5. I put 1, it's going to be 4, 1. And remainder is 1. And the quotient is 11. 11. Quotient is 11. Remainder is 1. Next. What is next? Now, R2 is going to be R1. I'm going to put here 4. And this is going to be what? 1. Okay? Now, 1 divided 4. 4 divided by 1. 4 divided by 1. This was like this. I put 4 here. And here I put 4. This is going to be 4. This is going to be 0. The remainder is equal to 0. The quotient is equal to 4. Now, R2 is going to be 1. R2 is going to be 1. This is going to be 0. Now, the GCD of 45, 4 is equal to 1. Correct? Okay. Fine. Is equal to 1. Fine. This one is equal to 1. Next. What is the next? Next, you are going to use that inverse and replace. We are going to use the inverse and replace. Inverse and replace in the sense, the other method to find the extended Euclidean. Look here. Okay, this was the first way. All right, look the second way. The second way, we are going to have 45. Wait, let me change the marker. Okay, fine. Now here I'm going to take 45 is equal to what? 45 is equal to 11 into 4 plus 1. As I told you, I repeat once again. When you have the remainder which is equal to 1, you have to stop there. In the next step, you are going to do inverse and replace. Inverse, okay, reverse, not inverse. We do so-called reverse, okay, reverse and replace, okay, and replace, okay, reverse and replace. What do we do? 1 is equal to 45 minus 11 into 4. Correct? That's the value of 1. Remember, we want to find the integer which we multiply by 4 and to give us the remainder which is equal to what? Which is equal to 1. Okay? the remainder should be equal to 1. Now, as you can see, 11 into 4, when we take 11 minus 11 into 4, mod of 45, they give us 1, correct? Now, here is like to say, look here, look at this. Let me erase this side, okay? Let me erase this side. Here is as to say, what to say here is that to say minus 11 mod of 45, okay? Minus 11 mod of 45. What is the value for this one? Minus 11 mod of 45. What is the answer for this? First, say first. What is the answer for this one? Remember, we cannot have the negative residue, okay? What is the answer for this? First, and you need to say first. Is equal to 30?
34, sir.
34, excellent. What does it mean? We mean that 34 into 4 mod of 45 is equal to 1. Is equal to 1. So the inverse of inverse here, you write inverse, the inverse, okay? The inverse of what? The inverse of 4 mod of 45 is what? Is 34. Correct? Is equal to 34. If you're correct, okay? If you're correct, yeah, 34, correct, is 34. So this is it. If you calculate, please calculate, and then we do the last. This is the last, okay? Take 34 multiply into 34 multiply, we are going to take 34 multiply what? We are going to take 34 multiply 4. Let's look the proof. Everything has to have a proof and see if what we have done is correct. Okay, this is equal to 130. 100, is it 100? Yeah, 136, right? 4 into 4 is 16, right? 136. Am I correct? 136, correct, right? If we take 106, if we divide by 45, what to put, which number can we put there? If you put 2, if we put 3, let's put 3. 3 is going to be 5. 3 into 2 into 4 is 12, plus 1 is going to be 13. Residue is 1. Correct? We are correct. This is the inverse of 4. Is it clear to you all? Clear? Anyone has a doubt? Is anyone who has a doubt? Now I would like to receive that. If you have a doubt, you can ask. If there is no doubt, then I give you a number which you have to calculate, and then you send to me, okay? All right. So let me give you your assignment here, okay?